Hello guys, welcome back to a new chapter and a new video. In this chapter, we will be dealing with fluids and buoyancy. Section 1, we have fluids and buoyant force. Now, if you remember in the previous lesson, in the previous chapter, we talked about the states of matter. We had solids, liquids, and gases. And we learned each property of each phase. We learned that solids, they have a definite shape and a definite volume, and they have a fixed arrangement, and particles are closely packed. And then we talked about liquids. They have no definite shape, but they have a definite volume. Particles are close, but with no distinct arrangement. They are not regularly arranged. Then we had gases. They have no definite shape or a definite volume, and particles are loosely packed. They can move freely. In this chapter, guys, we are going to talk about fluids. Now, fluid, guys, is a non-solid state. What do you mean by this? It means it is either liquid or gas, okay? For example, you have water for liquids, you have juice, you have honey, okay? All of these are what? Are liquid. Or you have gases like oxygen, carbon dioxide, hydrogen, helium. All of these are called fluids. So in this chapter, whenever you hear the word fluid, we are referring to either a liquid or a gas. If we define fluids, we will say they're a non-solid state of matter in which the atoms or molecules are moving freely. We have two properties, guys, of fluids. They can change their shape and they can flow. For example, you have water. Water can flow very easily. You have rivers, you have sea. Or when you are pouring water from a jug into a glass, this is what? This is a liquid flowing. And you see that the water takes the shape of the container. So, or you have gas. If you have a balloon, if you press that balloon, if you compress this balloon, you can see that the gas in the balloon is going to change easily. So this is what these are the properties of fluids. They can flow, meaning they can move, and they can alter their shape, or they can change their shape. If you are asked why solids are not considered as fluids, because they cannot change their shape and they cannot flow too. These are the differences between solid, liquid, and gas. You learned that in the previous chapter. Solids, they have a definite shape, they have a definite volume, and they cannot flow. Particles are tightly packed with a fixed arrangement. Liquid, they have indefinite shape or no definite shape, but they have a definite volume. They can flow. Particles are close, but not, they don't have a fixed arrangement. Gases, they have a definite shape, no definite shape and no definite volume, and they can flow. Particles are free with no distinct arrangement. If I tell you what's the difference between liquids and gas, it's the definite volume. Liquids, they have a definite volume, but gases, they have no definite volume. The common thing between them is that they have no definite shape, gases and liquids, and they can flow too, okay? Now we have density and buoyant force. Now, density is what? Density, the equation of density is rho, which is equal to mass over volume. This is called density. This is the symbol of density, which is pronounced as rho. It's not P, careful. This is rho. And this is mass. Mass is measured in what, guys? Mass is measured in kilogram, okay? And this is volume. It is what? It is measured in cubic meter. Now, if you have an object, okay, and you have something in it, let's say you have, it's filled with something, okay? You have what? You have volume, okay? So you have what? You have a unit volume. And the thing that is in here, let's say you have some bowls or anything in here. Oh, it's a bag, it has tomatoes or cucumbers, anything in it. So it's a what? It's a unit of volume. It has what's in it? It has some mass in it. The measure, guys, the measurement of mass here in a unit volume is called density. Or for example, you are in a room, okay? The room has a volume, okay? It has a unit of volume. The measurement of the mass in this room in a unit of volume is called what is called density, okay? The relationship between mass and density is directly proportional, okay? So if mass increases, density increases too, okay? If you have more objects in your room, then the density of the room is going to increase, okay? If you have less masses or less objects in your room, then the density of the room is going to decrease too. So if mass decreases, density is going to decrease too. Volume with volume, density is, a density with volume is indirectly proportional, okay? It's inversely proportional. If volume increases, imagine if you have a bigger room, okay, you can put more stuff in it, so the density is going to, what is going to be? Decreasing. So if volume increases, density is going to decrease. So let me write this one here. This one is directly proportional, meaning if mass increases, by the way, this is like this, density with mass. If mass increases, guys, density is going to increase too. But with volume, it's what? It's inversely proportional. Inversely proportional. Meaning if volume increases, density is going to decrease. If volume decreases, density is going to increase. This is the unit of density. Now, if I ask you what does density depend on, density depends on two things, guys. It depends on the mass and it depends on the volume too. The volume of the object or the mass of the object. Now, guys, this is for density. So if we define density, we will say density is mass in a unit of volume, and the unit of density is kilogram per meter cubed. Why gases, or let's ask another question, why is solid, or why are solids denser than gases? It's because the particles or the atoms in solid are closely packed together, while in gases, particles are loosely packed, okay? And in liquid also, particles are what? Are close together, okay? That's why the density of solids and liquids is higher than the density of gases. Another question, why pressure does not change the density in solids and gases significantly? It's another question, but you can answer it with the same answer in the above question. It's because particles in solid and liquid are closely packed, and they have a small distance between them, whereas in gases, the particles are what? Are loosely packed. Now, guys, you have a table here. This is what these are the densities of some of the common substances you have. You have hydrogen, helium, steam, air. You don't have to memorize any of them, but I think you should memorize this one. It depends on your teacher, but I think you should memorize this one, which is fresh water, which is equal to 1 times 10 to the power of 3 or 1,000 kilogram per meter cubed. Okay, this is the density of water. As you can see that the fresh water is what is 1.025 times 10 to the power of 3. In the problems, in the questions, you'll be given the density of the other materials, so you don't have to memorize any of these. But just know that the density of fresh water is equal to 1 times 10 to the power of 3 kilogram per meter cubed. Now, guys, we have buoyancy or buoyant force. Now, if you know how to swim, And if you have ever been in a swimming pool, when you go inside the water, you feel that your body is what is having, or it feels lighter, okay? You feel lighter in water. What's the reason? The reason is that water applies, let's say this is water. Okay, let's say you have a water here, and then you have an object. You have an object here, which is floating in the water. Now, guys, if you have ever been in a swimming pool, when you swim, your body, or if you are swimming with your friend, you feel that the body feels lighter in water. The reason is, guys, because water applies a force which is opposite to the weight of the object. We call it buoyant force, okay? So let's say this is the weight of the object, okay? This is the weight of the object. We call this Fg, okay? We call this Fg. Fg is the weight of the object, guys. And a force is applied opposite to the direction of the weight of the object, which is called what? Which is called buoyant force, okay? And we represent buoyant force with Fb. So this is what? This is buoyant force, okay? Which acts in the opposite direction of the weight of the object. You see, the weight of the object is what we call in the downward direction, but the buoyant force is what? Buoyant force is in the opposite of it. Or we can say that buoyant force is acting opposite to the force of gravity, okay? Some of the things that you should know here are these. Fb is buoyant force. Fg, guys, is what is the weight of the object in air, okay? The weight of the object inside water or in the water is called F apparent, okay? F apparent. This is called what? This is the weight of the object, or you can just say Fa, okay? This is the weight of the object in water, because the weight of the object in water is less than the weight of the object outside the fluid, okay, or outside the water. So you have Fb, which is buoyant force, you have Fg, which is weight of the object in the air, and you have F apparent, which is what? Which is the weight of the object in water. And all of them are measured in what? In Newton, careful. The unit of them is what? Is Newton, okay? The unit of all of these is Newton. Now we have what? We have the three cases for buoyancy. Before that, let's read this one. Buoyancy acts in the opposite direction of the force of gravity. As you see in here, this is the force of gravity, and buoyancy is what? Buoyancy is in the upward direction. Objects submerged in a fluid such as water have a net force on them that is smaller than their weight. This means that they appear to weigh less in water, okay? So as we talked about here, objects in water feel lighter. This is because a force is applied on them. They experience a force which we call it buoyant force, okay? Apparent weight is, as we studied, is the weight of the object in an immersed in a fluid. Now, guys, we have three cases when we are dealing with buoyancy. When the object is completely sinking in the fluid or in the water, the Fg, or the weight of the object, is greater than buoyant force, okay? Or you can say that the density of the object is greater than the density of the fluid, or the density of the liquid that you have, which is water here. If the object is standing in the water, we say that Fg, which is the weight of the object, is equal to the buoyant force. Let's say here Fg is equal to 20 Newton and buoyant force is equal to 3 Newton. Let's consider it like this. So here the object is going to sink. Why? Because buoyancy is smaller. The force of buoyancy is smaller than the force of the weight of the object. You have here this one. Let's say here 3 Newton, which is the weight of the object, is equal to 3 Newton, which is what? Which is the weight of buoyancy, the force of buoyancy. You have this one, the third case, when the magnitude of the buoyant force is greater than the weight of the object. So for example here, you have 3 Newton, which is the buoyancy, is greater than, let's say, 1 Newton, which is the weight of the object. Here the object is going to float. Or if you can relate that to density, in the first case, A, if the density of the object is greater than the density of the liquid, then the object is going to sink. If the density of the object is equal to the density of the liquid, then it's going to stand in the water, like this, okay? If the density of the object is less than the density of water, then it's going to float on top of the surface of the water. Like, for example, a sponge, a paper is going to stand or float on the surface of the water. Now guys, we will reach something else, which is called Archimedes' principle. Now, very simply, Archimedes' principle states that if you have an object which is completely or partially submerged in water, this is going to what? If you have an object like this, for example, let's say you have an object which is which is equal to 2 kilogram. If you have an object which is here 5 kilogram, let's say 5 kilogram. If you throw this object inside the water, inside the fluid you have, let's say you have a small opening here, it's going to be pouring into a small container that you have here. Now, of course, if you throw an object inside a fluid or inside a liquid, which is water here, it's going to displace the water here. It's going to make the water here move, or it's going to make it rise, okay? The amount of the displaced, the amount of the moved fluid, of the moved water, is what is equal to the weight of the fluid displaced, okay? So buoyant force here, guys, look, FB here, guys, which is the buoyant force. So if you, for example, throw this object here, the amount of water here is going to be what? Is going to be the weight of the displaced fluid, okay? Which is equal to what? Which is equal to the buoyant force. Careful, we are not saying that this amount of water is the weight of the object. No, it is the amount or the magnitude of the buoyant force that is acting on the object. Careful, okay? So the FB is equal to what? FB is equal to FG, which is the weight of the object. Buoyant force is equal to what? Sorry, here, let's write it here. Is equal to weight of the displaced water. Okay, and this is equal to what? This is equal to mg, okay? This is equal to mg, which is mass and the gravitational acceleration. You will learn this when we are dealing with problems using this equation. Just know that FB here is equal to Fg. Buoyant force in Archimedes' principle is equal to the amount or the weight of the displaced fluid, okay? Which FB is equal to mg, and m is the mass, and g is what is gravitational acceleration, is equal to 9.81 meter per second squared. You have many equations, guys, here. In the first, they seem a little bit confusing, but when you deal with questions, when you solve problems with it, they become simpler and simpler. Guys, you have this equation. When an object float or sink depends on the net force on it. This net force is the object's apparent weight and can be calculated as follows. If you want to calculate the apparent weight of an object, you should add buoyant force and the weight of the object. Then you will get what? You'll get apparent weight, okay? You'll be dealing with this equation a lot, so please try to memorize it. For a floating object, guys, for a floating object, the buoyant force equals the weight of the object. So you have this one, which is this one, rho F, is the density of fluid, guys. That's written here, is the density of the fluid. Vf is the volume of the fluid, and rho naught is the density of the object. V naught is the density of the object. This equation, guys, is used for what? When the object, guys, is partially submerged in the water. So for example, here you see this is the volume that is submerged in the water. So you are going to use this equation to find the buoyant force, or find the density of the object, or find the density of the fluid using this equation. We studied this one. An object floats if its density is less than the density of the fluid, and an object sinks if its density is higher than the density of the fluid. Why don't ships sink, guys? It's written here because their weight is smaller than the buoyant force, and the ship is filled with air, which has a lower density than water. Now, guys, if you have a piece of metal, let's say, if you have a piece of metal, okay, if you throw this piece of metal inside the water, it's going to sink, okay? But you might ask, why ships that are made of metal but they don't sink? Because, guys, a ship displaces a great amount of water, okay? A ship has a large area, okay? So it's going to displace what? It's going to displace more water, okay? If it displaces more water, so buoyant force is going to be greater. That's why ships don't sink. Another factor that affects makes ships don't sink is the air inside the ships. The ship is designed in a way that is going to have too much air inside it, okay? And as you know, air is less dense than water, so it's not going to sink. If you have a bottle which is empty, and it's going to float on water. But if you fill it with water, it's going to sink, okay? This is the same for ships. Ships don't sink because they displace a great amount of water, raising the level or raising the magnitude of the buoyant force. And they trap air inside. The design of the ship is created in a way that is going to trap too much air inside it, and that way it's not going to sink. You will be dealing with this equation a lot, okay? Fg, okay, which is the weight of the object. Careful. Weight of the object. In where? In air. Object in air. This is weight of the object in air. Fb is what? Is buoyant force. This is what density of the fluid. And this one is what is the density of the object. Now, guys, look. Most of the time in the question, you don't have FB, okay? How do you find FB, guys? You will find FB using this equation, okay? So FB is what is equal to Fg, which is the object, the weight of the object in air, subtracted by what? By F apparent. Careful, memorize this equation as it is. You will use this one to find the density of the fluid or the density of the object as it is demanded in the question. Like I said, these equations seem a little bit confusing in the first place, but believe me, they will become much easier when we will be dealing with them. Now we have this question. Let's solve this question and you will know what we are dealing with. Now look, guys, you have a bargain hunter, okay, which he's purchasing a gold crown at a flea market. After she gets home, she hangs the crown from a scale and finds its weight to be 7.84 Newton. Guys, look, it says hangs from a scale. So a scale is what? It's the weight of the object in the air. Okay, it's not inside a fluid. It doesn't say it's inside a fluid. So it's what? It's a scale. It's in the air. Okay, it's not in water. So this one is what, guys? This one is, well done, FG. This one is weight of the object in air. Okay, why? Because it's not in a fluid. Okay, it doesn't say in a fluid. It says just what? She hangs the crown from a scale and finds its weight to be 7.84 Newton. Then she weighs, look, she weighs the crown when it is immersed in water. Now, you know, this is what? This is F apparent, or you can just say FA, but I'll write F apparent. This is what? The weight of the object in water. F apparent is what? Look, 6.86 Newton. Is the crown made of pure gold? Explain. Now guys, remember the equation we had for finding the density of an object. You see, this is the object, this is the crown in air, this is the weight of the object, which is equal to 7.8 Newton, and this is the crown in water, which is equal to 6.68 Newton. Now look guys, we had an equation for finding the density of an object, okay? We have what? Remember, Fg divided by Fb is equal to the density of the material, or the density of the object, divided by what? Divided by the density of the fluid, okay? The density of the material divided by the density of the object. Okay, now look guys, do I have Fg? You should always try to answer these questions like this. Do I have Fg? Yes, I have it here. Do I have Fb? No. So let's find this one. Do I have the weight of the object, the density of the object? No, I don't have. Do I have the density of the fluid? It says what, guys? It says water. So I have what? Rho fluid is equal to 1 times 10 to the power of 3 kilogram per meter cubed. This is what? This is the density of water, okay? Since the crown is immersed in water. And I have this one too, guys. I have this one too. Now, how do I find this one, guys? I have Fg and I have F apparent weight. Do you remember this equation? We had Fb, which is equal to Fg minus F apparent, okay? So this is what? This is equal to 7.84 minus what? Minus 6.86. Then what will be the final result? 0.98 Newton. This is what, guys? This is Fb. Now I have Fb too, okay? I found this one too. Now I have this one too. One thing that has remained is this one. Let's find this one, guys. Now, use the cross multiplication. Multiply this one by this one and multiply this one by this one. So you have Fg multiplied by rho F, then Fb multiplied by the density of the object. You needed to find what? You needed to find this one, guys. So divide this one by Fb and divide this one by Fb. This one cancels. This one cancels with this one. You only have this one left. So rho naught is equal to Fg multiplied by the density of the fluid divided by what? Divided by Fb. Fg was equal to what, guys? Fg was equal to 7.84 multiplied by what was the density of the fluid? The density of the fluid was equal to 1 times 10 to the power of 3 divided by what? Divided by Fb. We found Fb2, guys. It's equal to what? 0.98 Newton. Then you will have what? You will have 8 times 10 to the power of 3 kilogram per meter cube. Guys, this is pure gold? No, it is not. Why? Because gold, the density of gold is equal to 19.3 times 10 to the power of 3 meter cube. Okay, this is density for what? For gold. then this crown is not pure gold, okay? Because its density is less than the density of the gold. This is sample problem 3A. In the next video, we will be dealing with practice 3A. See you in the next video. If you have any questions regarding buoyancy and fluid mechanics, please ask me in the comments, and I will be responding happily. See you in the next video.